Yeah, camp on everyone. Let's start off. So last thing we did was this potential energy of a system. Others camps on. Great. So next thing, we define something called potential difference. So potential difference is defined as the potential energy difference. Now you can say change in potential energy per unit charge. So just like, force and field, technically both are same. The only difference is what? Field is nothing but force on a unit charge. Remember, that's the discussion we had. So whenever you think about, force, field, or energy and potential, don't get confused. These are not four different things. Force and field are one and the same. If you calculate force on a unit charge, it suddenly becomes field. Similarly, potential energy and potential, they're one and the same. Getting it? When you find the potential energy to a point charge, it suddenly becomes a potential. So if you think that way, right, it is easy to figure it out. So the potential difference, VR2, the symbol is V, VR1, is given by UR2 minus UR1 by Q. Now, if you take R1 as infinity, you always have to choose a reference line. If R1 tends to infinity, a reference, and we know U of infinity, we take it as 0. Suddenly, this formula becomes V of R is equal to potential energy at R by Q. So that means if you have a point charge Q, and there's a point P here, same definition, the way we defined it before. And if you're going to bring a small Q charge from here to here, then we get the potential energy of the system is K Q by R. So from the potential definition, it is U by small q. We get KQ by R. So there. So potential at point P is given by KQ by R. So this is potential at P due to charge Q. It's a scalar quantity, it just adds up. So that is the formula for potential at a point P. So exactly what does this mean? But let's say, example, we have a point A here, we have a point B here. It is given potential at A is 10 joule per coulomb. Potential at B is 30 joule per coulomb. The meaning of this statement is if you take a charge from point A to infinity, you get 10 joules. Plus, no? Infinity, what is the energy? 0. Right? At point A, the energy is given as 10 joules. So if you take a charge from A to infinity, you gain 10 joules. Right? U is the potential energy of a system, Or you can say like that, U is the potential energy gained when you bring it from infinity. right? So from here now, if you take a charge minus q, and if you're taking it from B towards A, where q का value is, let's say, minus 2 coulombs. Then the work done is given by, or the external forces. So you're going from B to A, so A is final, B is initial. So U final minus U initial is charged into potential difference VA minus VB. This is minus 2 into 10 minus 30. This is 40 joules. Means if you want to take this minus 2 coulomb charge from B to A, you need to provide 40 joules. You're getting how to use the potential. So if I know potential at 2 points, right? So what this is telling you is, in order to go from B to A, I actually lose energy if I take a positive charge. But if I take a negative charge, I need to provide energy. So the charges will take care, the signs also. So potential at a point simply tells you how much energy you gain if you go from there to infinity. For example, say at point A, if I say the potential energy is minus 30 joule per coulomb, what is the meaning of this? Anyone who is at point A is in depth. Until unless you give 30 joules to him, he won't go to infinity. He reverse that. You're getting the meaning of that? Understood the meaning of negative energy, right? We discussed last time. But say if VA is plus 30, means what? It's a repulsive system. This guy will automatically go to infinity without anyone helping him out. And in this process, he will give you 30 joules. Is that making sense? So infinity is like a zero level. When you have a positive potential, meaning it is going to give you energy if you go to infinity. If you have a negative potential, meaning you have to provide for it to go to infinity. Is this clear, everyone? That you can just note down this thing. So this is the main result there. Potential at a point is VQ by R. So remember, force and field are exactly same. Field is simply force on unit charge. Potential and potential energy is exactly same. The only difference is, technically they are the same things. Potential energy is between two charges, Q1 and Q2, whereas potential is between Q1 and 1. Basically, you made Q2 is equal to 1. And look at the formula KQ by R. So force is K Q1 Q2 by R square. Field is K Q by R square. Energy is K Q1 Q2 by R. So denominator will be single R. Potential is KQ by R. Clear? Let's see a question. We have an equilateral triangle. Here we have plus Q. Here we have minus 2Q. Here we have plus 3Q. O is the centroid. Point A is the midpoint of this side. Find field and potential at O and A. Straightforward formulas. Let's give it a try. Everyone should try. Give it a try. Potential is the easiest one. There's no vector, nothing. You can just get the magnitudes. One more minute. Let's see. So for the potential, if I look at VO, so that will be KQ by distance will be root 3 from here to here now. Should remember this. This result is how much? A by root 3. So this will be KQ by A root 3. So this will be 1 minus 2 plus 3. Isn't it? KQ by R minus KQ by 2R plus 3 KQ by 2R. So directly you can add it there. That guy will be 2 root 3 KQ by A. Potential at A will be KQ by the total height root 3 A by 2 minus K2Q by A by 2 plus K3Q by A by 2. It doesn't matter where they are. All matters is the magnitude. You can directly add this. Now, when it comes to field, now if you look at O here, the plus is pushing down. So I'll do one thing for convenience. I will write E is equal to KQ by A by root 3 whole square. So I'll call this thing E. Then 2Q will attract towards itself. So that will be 2E. 3E will push away from here. So this will be 3E, right? And you can clearly look at these angles here. Look at these angles here. So if this is 120, right, this angle will be 60. So this angle will be 30, isn't it? The total is 90, na? So wait, I'll do one thing. So this 3, right? Let me write it here. So this 3 will be like this. This is O. E ka value, you can put it as KQ by A by root 3 whole square. That is 30. This is 30. There, you're done. So field at O will be 3e cos 30, 2e cos 30, 5e cos 30 I cap. And in the vertical direction, you have 3e sine 30, 2e sine 30, and this is minus e. So that would be e sine 30 minus e j cap. So this guy will be 5 root 3 by 2 e I cap minus e by 2 j cap. That is the field at O, everyone. Remember, it's a vector quantity. You have to resolve into I cap, j cap, and then solve. Then if I do this for A, so this 3q is pushing this way. Now here I have to write the equation. So this is k 3q by a by 2 whole square. 2e is also attracting here. So this guy will be k 2q by a by 2 whole square. And that guy is pushing down. So that is kq by total height root 3 a by 2 whole square. There, you got it. I cap, j cap, finish it off. So this guy will be, field at A will be, how much is this? A by 2, it will go up 5, 4, 20. So that is 20 kq by A square I cap minus 4 kq by 3 A square j cap. That's your answer. Are the steps clear, everyone? There's nothing there. We just did vectors. Any doubts on this? Clear, Arush? Abhinav? Clear this? Sharman? Soham? Next one? Next one. Let's say we have a charge q at d comma 0. We have charge minus q 2d comma 0. It's a important question. This will something like this similar again will pop up in magnetism. 3-4 places you will see something like this. Plus q. It's not a tough one, but should know what is happening there. Minus q. So this thing is just alternating continuously. So on till infinity. So there are infinite charges like this, plus minus, plus minus, plus minus. Find the potential at the origin. Let's see. So first thing, let me give you a hint. So this is the sequence which I want you to know. Ln 1 plus x is given by x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on till infinity. If you have learned sequence and series, you will know this thing. So if I put x is equal to 1, I will get ln 2, which is 1 minus half plus 1 by 3 minus 1 by 4, so on till infinity. I think now you can see the sequence. So this is what you need to solve this question. So potential at the origin will be k q by d. Take out this common, then you'll be left with 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on till infinity. So most people don't understand where the hell you got the ln from. That's it. That is the only thing about the question. Suddenly in the options you will see ln 2 and you'll not understand where you get the ln term. That sequence which you form is actually ln 2. Yeah. Is this clear, everyone? Easy question. If you know actually what you're doing, it'll take 20 seconds, but yeah. Remember, there's also something in exponential series which we did in thermal expansion. E power x. 1 plus x by 1 factorial, x squared by 2 factorial, x cubed by 3 factorial, and so on. Clear with this? Next one. We have a charge m, q, going with speed u towards another particle, which is mass 2m, same charge q. Initially, they're very far. A mass m charge q is projected towards 2m from very far. Case 1, 2m is fixed, meaning you're not letting 2m move. Case 2, 2m is free to move. Neglect any other forces like gravitation and all that stuff. So find the minimum distance between the charges. As they come closer, they start repelling each other. So m slows down. So there will be some minimum distance between them. Get the second one also. Think. Take a minute. Let's see. Now, one thing. This is something, we had a discussion in mechanics, if you remember. When you see a question, how do you decide? See, this is still valid. Don't think like, we are doing electrostatics, so mechanics ignore karenge. When you solve a problem, let me show you this algorithm, if you remember, which we did. How do you decide whether you start a problem? Like, see, the biggest headache, right? How do we start a problem? Right? Unlike maths or chemistry, right? Physics, there's one advantage is that luckily we have only two primary, methods. So when you see a question, if you find words like this, find the tension force, find normal reaction, find time, find acceleration, when you hear these kind of words, right? So the thing is, tell me one thing. If I ask you to find tension force, normal force, you're talking about forces, right? It starts with a free body diagram. So we use forces and torques, we draw FBDs and solve. But if you see words like this, find the final speed, find the maximum height, find the final position, find maximum elongation, look at the words they're asking. I have given you some initial position and I'm asking you about something final. When you see a question, you get that feel like, question mein they gave some initial conditions and they're asking about something finally, and I don't care about anything in the middle. When you see these kind of words, we know it is conservations. So we draw the final diagram and we have three conservations: energy, momentum, and angular momentum. See which works and solve. Knowing this basic outline, right, you can handle more than 95% of the problems in physics. Wherever mechanics is involved, you will have an idea like how to start. Most people have this problem. They see a question, they keep staring like, what? So quite a useful thing. Don't forget this. So same thing here. If you see, I said initially very far, and I said finally there's a minimum distance. So I'm talking about initial and final. So this is clear. I have to use conservations. So I have three conservations here. So let's see case one. Can I conserve linear momentum? Can I conserve linear momentum? And it is easy to get an answer. Huh? I can write it in one step and get the answer, but they'll ask in more than one choice, you'll get stuck. Okay, why can't we conserve linear momentum here? There is an external force. How do you know that? He said 2m is fixed. Since 2m is fixed, meaning someone is holding it, or else 2m would have moved automatically. There is an external force. If there is an external force on a system, you can't conserve linear momentum. Meaning theoretical notions kahan se aayega? Like this only, when you actually think about what's happening. There, so linear momentum is gone. Great. Now there is an external force on the system. So can I conserve energy then if there is a force? Force तो है. What is the problem? How can you conserve energy when there is a force? Why, Ansh? Why is that? Right, Ansh, you got it. Anyone else? If there is a force, impulse has nothing to do with it. Internal. What internal you're talking? I wrote clearly it is external force. Negligible. Who said negligible? Gods. Even though there is a force, displacement of 2m is zero. What is work done? Force into displacement of point of application of force. Even though on the system there is a force, there is no displacement. Therefore, work done by external force is zero. Energy is conserved. This is what should go in your head when you're solving. Blindly, we put a steps and get the answer. Something changes in the question, you'll have no idea why the hell you're doing and what the hell you're doing. इतना clarity होना चाहिए why there is a momentum not conserved, why energy is not conserved. Now, if I actually have to solve the question, it won't take this much time. So this is very far, and eventually 2m is here. Now, people must have seen this question before, so you must have got the answer. But maybe you didn't think about all these things that is required. So this is our minimum. Angular momentum is anyway conserved here. It doesn't matter. So it's going in a straight line. So this is 1 and this is 2. State 1 and state 2. Momentum is not conserved. Energy is conserved. So initial state 1 is equal to energy final. Kinetic energy half mu square. Potential energy is 0 because you're very far. Kq q1 by infinity. Finally, kinetic energy is 0. Potential energy is kq square by r minimum. They're done. Ek step mein aa gaya answer. If you just want the answer, you will get it pretty fast. But what about the second thing? Case 2, now you're moving. Now there's no external force. So momentum is conserved, energy is also conserved. This is 2m, this is at rest. This is very far. Now one important question comes. At what position do you get minimum distance? Like, when do you get minimum distance? When they get minimum distance, can you say anything about their velocities? When you get minimum distance, both the blocks will have same velocity. Why is that? Think about it. If 2m is going faster than m, then the distance will keep increasing. If m is going faster than 2m, the distance will keep decreasing. This question has a lot of resemblance with this guy. Mass m, block given speed u, there is a spring here, 2m, and this is at rest. Remember this question from center of mass collision? And the question was find the maximum compression. The maximum compression occurs here when both the blocks have same velocity. Right? How is this related to this? Think about this. Tell me one thing. Mass is m, mass is m, mass is 2m, mass is 2m. Here we have spring force, here we have electrostatic force. Does Max care whether the force is electrostatic or spring force? Since the final situation looks similar, Max will say, okay, you're just calling spring energy as elastic, electric potential energy. I don't care about it. Mathematically, they look the same. So maximum compression occurs when velocity is same. Do you guys remember how did you find the maximum compression? There is a result we derived, a shortcut. Half k x max square. So this is your maximum potential energy is equal to half mu v relative square reduced mass. Where mu is equal to m1 m2 by m1 plus m2. So if you use this logic, I can directly write this is equal to k q square by r minimum. You'll get an answer in one step. But let's solve it anyway. So this thing, right, you should definitely refer in case you have a problem. We had a full-fledged discussion on this thing. This question, we had a full discussion on this. Page 111, we literally drew each and every situation that is possible here. And this is the shortcut if you remember, reduced mass. Half k x max square is half mu v relative square. This is so for page 111, center of mass collisions. So having this idea is important. Great. Now, how do we solve? So this is state 1 and state 2. Initial momentum is equal to final momentum. Mu is equal to mv square plus 2mvc. Vc is equal to mu by 3 or u by 3. Initial energy is equal to final energy. Initial energy half mu square, final energy half m vc square plus half 2m vc square plus the potential energy is kq square by r minimum. Take vc and substitute here, we will get kq square by r minimum. There will be mu square by 1 by 3, 3 by 2, 3 by 2, 1 by 3, half minus 1 by 6, 3 minus 1, 2 by 6, mu square by 3. Therefore, R minimum is 3 kq square by mu square. Check. But if you can actually relate this to the spring block, इतना करने का जरूरत नहीं था. You could have done with this, and you get R minimum. You can check this thing, see what is reduced mass. Half mu will be m into 2m, 2m by 3, v relative is v square is this thing. There, directly got the answer. In place of spring energy, you have electrostatic potential energy. When the compression is maximum, the blocks are at a minimum distance between them. So technically, if you don't tell the person who is solving the problem that you're dealing with a spring and you're dealing with the electrostatic potential energy, but just by seeing the equations, you can't tell the difference between them. This is one advantage you have. If the things look similar, you can repeatedly keep using the same stuff. Doesn't matter which chapter. This is already the third time you're seeing this guy. First time you saw in center mass collision, second time you saw in SHM time period. This is the third time you're seeing. You'll see this again in alternating current. That's what I keep telling you. Physics mein, that is one advantage you have. Mechanics, you should have a basic idea about everything. Clear with this. Any doubts on this? Let's see something better. Clear na Parth? Ojas? Clear. We have a mass m going with speed u plus q. There is another mass n which is very far. This is also going with speed u plus q. Initially, they're very far. As they start coming closer and closer, what will happen? They'll start repelling each other. So this guy, instead of going straight, will start bending like this. This guy also, instead of going straight, this guy also start bending like this. Making sense? Find the minimum distance between them. This distance is d initially. The perpendicular distance between the charges is d initially. Find the minimum distance between them. How will we do this? Think. One thing is clear. We have to use conservations. So can I use linear momentum? Yes, there's no external force on the system. Can I use energy? Yes. Can I use angular momentum? Yes. I can actually use all three of them. Now you need to see which one is useful and how do you do them. Linear momentum ka problem is this. At every point, if it is going this way, this is going this way, so there'll be always zero. So it really doesn't help. Energy is fine. Now angular momentum ka there is a problem. Angular momentum says if a torque about a point is zero, then the angular momentum about that point is conserved, isn't it? Now, where is the torque zero? About which point is the torque zero? MPT of line, MUN of this. Which abbreviation you're using, Riansh? Please use normal English. I don't understand the shortcuts of your generation. Think of me as an ancient person. What is MPT? Maximum police training. ऐसा कुछ. No. Most polite teacher. Something like that. Okay. This is a better word for all that, right? What you're saying, I have got it, but there is a better one than that. You can just say one thing. Look at this thing. Both the masses are moving, but there is someone else not moving. Center of mass. Center of mass will be stuck there only. Listen to this statement. Listen to the statement what I'm saying now. I think I told you this before, but listen to this again. If particles are not going in straight lines, and if particles are not going in circles, right? This is not going in a straight line, this is not going in a circle. Remember this thing. In 11th and 12th, we have no other way to solve this problem except only one method. Energy conservation, angular momentum conservation. Keep this in mind, helps a lot. You see any weird path other than a straight line or a circle, 11th and 12th, maybe don't have enough max to solve any other equation. The only way you can handle this is energy conservation and angular momentum. You will see this a lot, especially in gravitation. Gravitation, we have elliptical orbits and all that stuff. So we will deal with that. So look at this thing here. So as these things are moving, at some point, this guy will come here V. This guy will come here V. This will be your center of mass, and this will be your R minimum. And a few things here. The first point, if you see, the center of mass is at rest. At R minimum, you will observe these velocities are perpendicular to the D minimum. Why? If it is not perpendicular, what will happen? Think about it. If you have a component along the line joining, that means they're getting closer. If you have a component away from the line, then the distance is increasing. So at the minimum distance, the velocity along the line must be 0. So at R minimum, velocity component along the line must be 0. Therefore, velocity has to be perpendicular. The second point, if you see, electrostatic force, when they're repelling, when they're repelling here, the force is passing through the center of mass. When you're here, passing through center of mass, passing through center of mass. No matter how long they travel, you'll observe that they'll always pass through the center of mass. Electrostatic force always passes through center of mass. So if the force is always passing through center of mass, then torque is 0. Therefore, torque about center of mass is 0. Therefore, angular momentum about center of mass is constant. There, I got everything that I need. So let's see the equations. So this is initial state when they're very far, and this is the state 2 when they're the closest. What is initial angular momentum? Remember, angular momentum is m into perpendicular distance into velocity. I don't want the actual distance between the point and the center. I want the perpendicular distance. So L initial is equal to L final. So L initial will be mu, perpendicular distance is d by 2 into 2. There are two of them. This will be mv, distance is r minimum by 2 into two of them. So we get u into d is equal to v into r minimum. This is equation 1. Initial energy is equal to final energy. I think you'll get a quadratic, yeah. Initial kinetic energy of mu square into 2 times. Potential energy is 0 because they're very far. Finally, the kinetic energy is half mv square into 2 times plus k q square by the minimum distance between them, r minimum. Take that v and substitute here. This will be mu square and this will be m into u square d square by r minimum square. Yeah, numbers are given, you can solve this, but there you got it. Solve this, you'll get r minimum from here. Energy conservation and angular momentum. So remember this, If you see a problem and this particle is going in some weird path and they're asking initial and final state, there is no other way. You have to use energy and angular momentum. And you will keep encountering this a lot. Gravitation will encounter a lot. So keep this in mind. Is this clear, everyone? Can you tell me what is the trajectory of that red line? If someone asks you, what is the shape of that red line? Parabola, hyperbola, circular arc, or something else, whatever cycloid, if they ask you something like this, what is it? Hmm. It's actually a hyperbola. It's if you see these things are like asymptotes. Look at this. Initially, when the M was here, it's going like this. This was the center of mass. So initially, what was the perpendicular distance? D by 2. Your speed was u. At infinity, when you go to infinity again, what will happen to your speed? At infinity, again, your speed becomes u. So to maintain the same angular momentum, the distance will again become d by 2. It's basically like an asymptote. This is a hyperbola. And at this point, you can make this question even more dangerous. We will see this in advanced revision. If you take this angle here, delta is the angle of deviation. Now, finding that is a different game. We will see later on. They can ask you like that also, find delta. But for now, remember this, it's a hyperbolic trajectory. Is this clear, everyone? There. So till now, what we did was all point charges ka field and potential, and it's all based on point charges. So what happens instead of a point charge, if you have a extended object like a rod or an arc or a disc or something like that? So that's the next part. Everyone clear with this? So remember the formula kq by r and all these things were derived for point charges. So first thing is a uniform rod. Now, how to choose an element, how to integrate all this stuff we did discuss in center of mass and moment of inertia. Ideas are still same. You're just dealing with a different thing like a field. So we have a rod here. Let's say it's made of positive charge. Lambda is the linear charge density. If you remember in center of mass, this used to be linear mass density. Unfortunately, physics we don't have enough symbols, so we use the same thing for everything. This is the point P. L is the length of the rod. D is the distance between the end of the rod and point P. Find field and potential at point P. So remember, lambda is charge per unit length. So these are some of the terminologies we'll keep seeing. So is the linear charge density. Sigma is charge by area. This is surface charge density. Rho is charged by volume. This is your volume charge density. Now, when you give me a question like this, a rod and everything, listen, I have a brilliant idea. What do you guys think about this? Can I replace this whole rod at the center of mass with a charge Q and then find the field and potential? What do you think about this? And just don't shake your head. Give me a reason why not. That is an important thing you need to ask. When something is there, you should tell why or why not. Nah? Just shaking your head is what. We are not in an arts class where you can feel it. You don't tell me like, sir, I think it is wrong. My feelings are telling me. Like, we don't care about your feelings. This is a physics class, not feelings class. Charge is only concentrated at center of the. What are you even talking, right? What are you even talking? It's like I'm asking, like, why are you getting less marks in the exam? वो क्या है ना China में production which is there that is getting hampered because of this Mongolian tribes. I said, what the hell are you even talking? मतलब getting समझ में आ रहा है कितना different हो रहा है? You're messaging something like that. Center of mass varies linearly. Distance changes with each point. Someone said something. Center of mass. Nay, God, listen. Whenever we use center of mass, it works only for linear functions. Center of mass का formula क्या था? Sigma mi ri r power 1. You can use center of mass concept only when functions are linear. But here field is 1 by r square. Potential is 1 by r. It doesn't work. I know it might look weird, but what happens, in the exam, in the tension, right? I have seen people thinking this might will work. But here, if you see E is proportional to 1 by r square, so it is better I break this thing in the beginning only, right? Never use center of mass concept for field and potential. Finding E, var, and V. Then you might ask, sir, but हमने एक question किया था last time, उसमें तो हम center of mass use किया था. Now, if you go back to that question, you can ask yourself, how did I use center of mass? I didn't use center of mass for field. I said the field is constant. I said force is field into charge. Charge is power 1, isn't it? Here field is linear. यहाँ पे field जो है ना, E is constant ना, E is not changing here. So F is EQ, F is equal to mg, G into M. So Q and M are looking identical. So this is what we use center of mass for. So if you put a charge in a constant field, the force will act on the center of mass. That's what we said. Are you getting this? Because force is Q into E is a linear function, Q power 1. Is this clear, everyone? So never use center of mass for finding field or potential. Don't replace the rod with this thing. It doesn't work. Now get this. So keep this in mind, just in case. This, even if someone does this mistake, right, it's a little decent mistake. In the exam, in the tension, we do more hopeless mistakes. When 12 minus 8 becomes 20. 3 into 3 becomes 6. Right? 3 into 3, 6 is my favorite mistake, which I did in the final chemistry paper also. 12 minus 8, 20 is your senior who did this last year. 730 rank IIT Bombay electrical. So people do dumb mistakes. How do we handle this? Yeah, potential will be in log. Let me show an element. Listen, I'll show you one. Remember, the only formula you know is kq by r. That is only for point charges. Interestingly, you gave me a big rod. So what we do, from point P at a distance x, consider a very thin slice, dx. So the idea is this, dx is so small, I can treat it as a point charge. So dq will be lambda into length. So that is a point charge. So field due to this point charge will be k dq by x square I cap. I can still use the formula for a point charge. So substitute here, this will be k lambda dx by x square I cap. So this is the first thing. In physics, the actual integration is easy. The headache is converting the problem into integration. This is the first part, choosing elements. Second thing, the limits. What is x? X is the distance between point and the dx piece. So x is equal to 0 is here. This is x is equal to d. And this is x is equal to L plus d. Meaning your rod starts from x is equal to d and ends at L plus d. You're getting the meaning of that. So now when you try to find the field at point P, integral d. This will be k lambda integral dx by x square I cap. Limits will go from d to L plus d. There, that integration is easy. 1 by x square integration is minus 1 by x, which is 1 by L plus d minus 1 by d. dd will cancel. You'll have L there, and you will end up with k lambda L by L plus d into d. You can check it out on your own. There will be a field, everyone. Similarly, for potential, we do the same thing. dV will be k dq by x. So I'm still using the same formulas we did for point charges. The potential at P will be integral k lambda dx by x. Limits will go from d to L plus t. So understand, x is the distance between the dx piece and the point P. So the first dx piece will start at x is equal to d, and the last piece will start at L plus d. This guy will be k lambda. You'll get ln L plus d minus ln d. So that is ln A by B. That's your answer, everyone. Is that clear, everyone? I'm skipping the steps in integration. I hope that much you can handle. So whenever you see a rod, the element always has to be a dx rod. And you can clearly see the formulas. You won't get this kind of answers with center of mass. लॉन तो डेफिनेटली नहीं आएगा. Clear with this? Next one. Any doubts on this? Next one. Next one is quite an important thing. I would definitely want you to mug up this result. Saves you time because the same result I can use it in gravitation. Whatever I'm deriving here, everything will be same in gravitation. सिर्फ k का प्लेस में कैपिटल G आएगा, lambda will be lambda, L will be L, everything will be same. You just have to put a minus sign. So we have a finite rod. Charge density is lambda. This is point P. Theta 1 is an angle with the positive edge, an upward edge. This angle is theta 1. This angle is theta 2. And d is the perpendicular distance from point P to this rod. You're getting it? The P is not symmetrical. P is somewhere there, different angles. It's not symmetrical. Find the field at point P. Theta 1 and theta 2 are angles with the upper and the lower edge. Take a minute or two. How do you get the element and all? Then let me show you this. You should have seen something like this. Let me show you. So how do you choose an element here? Listen carefully. The more than the actual thing, right? How did you choose an element? How did you integrate this idea is important. And these are the kind of derivations, which are and you can expect in advance, like, and you should know how to choose an element and stuff, how to take an element. Like I said, the actual integration will be easy. The headache is converting this into this. And these things, right? You learn, how, see, whatever we're doing today, after the class gets over, take a rough paper, see the question and try to replicate it. You should do this on your own. Only then, you will get an understanding like, okay, this is how I choose an element. It should be like pretty, you see a question, integration should not be scared of. I think once you reach that stage, it will be quite comfortable for you. Because max may they will teach you integration, but it will not be like this, getting an int limits and all that stuff. So this is point P. Now, one thing I tell you, see, no matter how you keep the rod, to rod S or a core rod S or a element always has to be like this only. You can't choose, elements like this. So at a distance x from here, choose an element dx. So this small dx here will have a charge dq, which is lambda into dx. So this guy is giving a field like this, which is d. And let this angle be alpha, let this distance be d, and let this distance be smaller. Now remember, whenever you take fields, you always have to integrate the vector. You cannot integrate d bar directly. You have to resolve into I cap, j cap, and then integrate components separately. So what is dE bar? So dE will be k dq by r square. K dq will be lambda into dx, and r square will be x square plus d square. So dE bar, when you resolve this into components, we will get k lambda dx by x square plus d square cos alpha I cap minus sin alpha j cap. Unit vector, everyone. De cos alpha, de sin alpha. Agreed? Then you integrate. Now, we did this thing long back in calculus, if you remember, how to integrate a vector. How to integrate a vector. If a vector is given, axi cap, ay j cap, az k cap, you integrate each component separately. Keep that in mind. You just can't integrate DE directly. You have to resolve into components and integrate each one separately. So the headache is, I have alpha, I have x, two variables. And remember, the limits are in terms of theta 1, theta 2. So we use something called integration by substitution. So tan alpha is x by d. So we have x is equal to d tan alpha. There, that came from the triangle. Differentiate on both sides. If you differentiate on both sides, this guy will become dx and this will become d secant square alpha d alpha. Substitute everything there. Now this thing looks dangerous, but you will notice something. K lambda dx becomes d secant square alpha d alpha. Denominator becomes d square into 1 plus tan square alpha, which is actually tan secant square alpha again. This will be cos alpha I cap minus sin alpha j cap. So secant square alpha and 1 plus tan square alpha, this guy and this guy will cancel off. This whole thing. We end up with dE is equal to k lambda by d integral cos alpha d alpha I cap minus sin alpha d alpha j cap. There, the integration has become quite easy actually. All that x and everything is gone. The integration finally came out to be a simple cos alpha and simple sin alpha integration. Look at the steps. This method of integrating, right, substitution is called integration by substitution. One of the simple technique you learn in maths. But physics may generally we don't go beyond this much integration. Have a look at this. Then, now, like I said, how do you put the limits? Now listen carefully with the limits here. So when we have the rod here, you said alpha is the angle. Now ask yourself, if you're exactly here, what is alpha? 0. So if I want to go upward here, 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 this alpha angle, you can clearly see you are rotating in this direction theta 1. So at this point, alpha will be plus theta 1. Similarly, if you go downward, you have to rotate in the opposite direction, theta 2. So alpha will be minus theta 2. So this is important. If you're rotating your angle in two different directions, you'll get angles from minus to plus. So when the alpha is positive, you're going upward. When alpha is negative, you're going downward. So now the limits will be integral EP, integral dE bar. This guy will be k lambda by d is constant, integral cos alpha d alpha I cap. Limits will go from minus theta 2 to theta 1 plus integral sine alpha d alpha minus theta 2 to theta 1 j cap. K lambda by d cos alpha ka integral will be sine alpha. Put the limit sine theta 1 minus of minus sine theta 2. That will become sine theta 1 plus sine theta 2 I cap. This will be sine alpha ka integral is minus cos alpha. Then you put the limits there. You'll get cos theta 1 minus sine cos alpha ka integral is what? Minus, wait, I did a mistake here. Yeah, minus tha already. Yeah, so minus here. So minus of minus becomes plus, and this will be cos theta 1. Cos of minus theta 2 is cos theta 2 j can. There. This is your final result. But let me put this in a more usable form. Because यहाँ पे I cap J cap now it looks okay. Problem ये होगा if I keep the rod like this. Now if you ask what is the field here, what is I and what is J? Should I take this way or upward or should I take down? So that is the confusion you get. So let me show you how do we put this thing. This is how I would prefer to write. This is point P. Now here, what is theta 1 and what is theta 2? Your choice. You can take any angle is theta 1, any angle is theta 2. So you take the up angle is theta 1, down angle is theta 2, it doesn't matter. So, so this component will be k lambda by d sine theta 1 plus sine theta 2. This was easy. This was away from the rod. इसमें problem नहीं आएगा. You take anyone as theta 1, theta 2, you'll get the same thing. Theta 1 and theta 2. This is away from the rod and perpendicular to the rod. The other component we take like this. So k lambda by d cos theta 1 minus cos theta 2. This will be towards theta 1. There. So the signs will take care of themselves. You don't take tension, sir, but I know field is downward. The signs will take care of themselves. For example, like I'll just show you. For example, if you give me a rod like this, you give me a point P like this, and you tell me this angle is 60 and this angle is 30. Now, what will you take as theta 1? What will you take as theta 2? Doesn't matter. Take 30 as theta 1 and 60 as theta 2. Then a component towards theta 1 and away from the rod. You're getting it? It will be cos 30 minus cos 60. But if you take theta 1 as the other angle, then it will be this way, and it will be cos 60 minus cos 30. समझ में आ रहा है? So वो confusion नहीं होगा. What is theta 1? What is, you choose anything. The direction will take care of it. You should put down this thing. We will need this result. Everyone should copy it down. We're going to solve problems based on this. So quite a useful one. If I put theta 1 is equal to theta 2, it becomes an angle bisector, mid perpendicular bisector. If I put theta 1, theta 2, 90, it becomes an infinite rod. So by putting different angles, I get different shapes. You should definitely mug up this result. Helps a lot. Clear, everyone? Yeah, it's perpendicular to the rod. Away from the rod and perpendicular to the rod. Now, case 1. Let's say theta 1 is equal to theta 2 is equal to 90. This becomes an infinite line charge. What will be the value for this? So if you put theta 1, theta 2, try to understand the meaning of it. Theta 1 and theta 2 are angles with the edges. So this angle is 30, 60, 80, 89, 90. They will become parallel, isn't it? So you're talking about an infinite rod. So here there will be no component parallel to it. The component will become simply 2k lambda by d. And how will the field lengths look like? So field lengths are the field lengths would look something like this. They will be coming out of the rod radially away. Ever seen this thing? Some people have that comb. Comb may you have spikes like this, like a cylinder. कभी देखा हो comb? You put the comb and you rotate and you do that thing. So it kind of looks like that. The field lengths are coming away from the rod from the center in all directions. Clear? Then if you look at case 2, let's say theta 1 is 90 and theta 2 is 0. We get a semi-infinite line charge. Meaning one side is infinity. Point P is here. We have k lambda by d and k lambda by t. Now this third case is important. This is where people mess up a bit. Tell me one thing, what will you take angles for this guy? Suppose someone gives you angles like this. This is 30. This is 60. What is theta 1 and what is theta 2? There is a difference. Suppose if it is like this. This is 60, this is 30. Both are 60 and 30. How do you take the angles? Now, if you go back to the derivation, you'll realize something. Look at this in the limits. When you took limits, what did you do? You took this is theta 1 because you're going up, and you took this as minus theta 2 because it is going down, meaning the whole derivation was done under the assumption theta 2 will go down, and that's why you took minus theta 2 here. But if the theta 2 was going up, what would have been the limits? Theta 2 to plus theta 2 to plus theta 1, right? So theta 2 is supposed to be down, right? But if you take theta 1 also up, then the angles will be theta 1 will be 60 and theta 2 will be minus 30. Here, this will be 60 and this will be plus 30. You're getting the difference? So be careful with that one thing. People generally do a mistake. They give this question, people put both positive and solve, and you get a wrong answer. Theta 1 is supposed to go up and theta 2 is supposed to go down. But if both are going up, then theta 2 must be negative. Is this clear, everyone? Take a break. Come back by 7. We'll continue from here again. So remember the result. We'll do problems based on this now. Any doubts so far? Chalo, come back in 10 minutes. Let's see. So let's start off with a question. So let's say we have x, y, z axis, x, y, and z. Make this y and make this z. So let's say this thing is made of lambda 1. So we have an infinite line charge along x-axis, and let's say this is lambda 2 and this is lambda 3. And we have a point P here, which is d comma 0. Let's make it x comma y comma 0. It is an xy plane. Find the field at point P. So we have 3 infinite line charges along x, y, z axis. How do we do this? Let's see. Remember, what is the formula for infinite line? 2k lambda by d. What is d? Perpendicular distance. What is the direction? Away from the wire. So let's do one thing. Let's color up each one. So let's say this thing I'll mark with red color. So for this, the point P, what is the perpendicular distance? Y, na? For x-axis, the perpendicular distance is y. So this field will be in this direction, which is 2k lambda 1 by y, and the direction will be j cap. So the x-axis ka line will give you field in the y direction. Let me mark this y-axis with green line. So iske liye the perpendicular distance will be x, and this will give field in the direction 2k lambda 2 by x I cap. Are you getting this? For the x-axis, y coordinate is the perpendicular distance. For y-axis, x coordinate is the perpendicular distance. For z-axis, I'll use this black color. What is the perpendicular distance? This, na? Root over x square plus y square. And this field will be in this direction, which is 2k lambda 3 by root over x square plus y square, and the direction will be OP cap, the unit vector. What is OP cap? OP cap will be xi cap plus yj cap by its own magnitude root over x square plus y square. Therefore, the field at point P will be 2k lambda 2 by x I cap plus 2k lambda 1 by y j cap plus 2k lambda 3 by root over x square plus y square OP cap. It's mostly figuring out the distances in the vector form. Check it out. If I had given you some numbers, it would have been more easy to get it, but yeah. Check out the steps. Clear, everyone? All got this? Next one. Next one. We have an infinite line charge bent at right angles. Meaning you have it on positive x-axis and positive y-axis. This is origin. This is point P, which is D, comma D. Find the field at point P. How do we do this? Let's see. Hmm, that looks right, I guess, Poroja. So treat them as two finite wires. So this is the point P here. Now look at this. So the one side is going parallel to this guy, and the other guy is this way. So this angle is 90 degrees. So I'll take theta 1 as 90, and I'll take theta 2 as 45. You can choose anything, but fine. So how are the fields? Away from the rod, 2k lambda by d sine theta 1 plus sine theta 2. The other component will be towards theta 1, 2 नहीं आएगा. K lambda by d cos theta 1 minus cos theta 2. See there, technically speaking, I know field should be down. The signs will take care of it. Cos 90 becomes 0. So similarly, if you take this point P here, now I will change the angles. This time I will take this 45 as theta 1, and I'll take theta 2 is 90. So it doesn't matter what you want to take, you take. This guy will be this way, which is K lambda by d sine 45 plus sine 90. This will be this way, K lambda by d cos theta 1 minus cos 90. There, these are the four components. So now if you try to put it at point P, so if you look at the red one, so this guy will be K lambda by d 1 plus 1 by root 2. This guy will be cos 90 is 0, it's a minus sign, so K lambda by d root 2. This green one will go up, K lambda by d 1 by root 2 plus 1. This will be this way, K lambda by d root 2d. You can clearly see it is done. So we get component here K lambda by d, and we get component in the upward direction K lambda by d. There. So field at point P will be K lambda by d I plus j cap. Are you getting how to take theta 1, how to take theta 2 now? So it doesn't matter. आप choose करो. Any angle is theta 1, any angle is theta 2, you will get the same. Have a look at this. Any doubts on the angle part? Please ask me. Clear? The next one. Any doubts on this? Great. Next thing is an arc. So if you have an arc, lambda, r is the radius, O is the center. This is theta. So it's a positive charge here, and this is angle theta. Find the potential and field at center. How do you approach this for an arc? Do you guys remember how to choose an element for an arc? We did this in centromas again. This is an arc. How did you find the center of mass? See how we choose an element? From the angle bisector at an angle alpha, we took a small angle d alpha, and then we found a small piece r d alpha, and then we tried to solve. So this is what I keep saying. Doesn't matter which chapter, the idea of choosing an element is same. Try, take a minute more, then I'll show you one. 2k lambda, yeah, something like that, Palak. See, so with respect to vertical at an angle alpha, take a small angle here, d alpha. So this piece here will be, length will be how much? R d alpha. So we have dq is equal to lambda into R d alpha. So that's a small charge dq. So this guy will give a field in this direction, which is dE bar. If that is alpha, this is also alpha. So dE will be k dq by r square, which is k lambda by r into d alpha. But remember, you always have to integrate a vector form. You can't integrate this directly. So dE bar will be k lambda by r d alpha. Vectors will be minus sine alpha I cap minus cos alpha j cap. You can clearly see here all the I components will cancel out. यहाँ पे भी एक component आएगा, इसका field ऐसा होगा. So by symmetry you can see there will be only j component left out. There's a field at the center. Now what are the limits? Remember, when alpha is 0, you will be at the center. If you rotate towards the right side, alpha is theta by 2. If you rotate towards the left side, alpha is minus theta by 2. Are you getting how I'm choosing the elements? So when you rotate from minus theta by 2 to plus theta by 2, I cover the whole arc. You have to go right and left. K lambda by r, take out the minus sign out, integral sine alpha I cap minus theta by 2 to theta by 2 plus integral cos alpha minus theta by 2 to theta by 2 j cap. So if you integrate this, you will end up, this term will turn out to be 0. You end up with 2k lambda by r sine theta by 2 minus j cap. Basically downward. Check out that much integration you can handle. Potential is the easiest one. Potential is a scalar quantity. So simply kq by r, all are equidistant. What is q? Lambda into r theta. So k lambda theta. That is the potential due to an arc. There is no integration, nothing for potential. Every point on the arc is equidistant from the center. So you can directly take k into total charge by radius. And the total charge is lambda into total length, which is r theta. Check. Have a look at the integration. So if I put this in a form, look at this. So lambda r, this is theta. The field will be along the bisector. How much is that? 2k lambda by r sine theta by 2. Now mains mein they'll ask me something like this. If you put theta is equal to pi, you get a semicircle. And if you see the result, you get 2k lambda by r. Doesn't it kind of look like that infinite line charge ka formula? 2k lambda by d, 2k lambda by r. Now, why do you need to know this integration? Because examiner, sometimes they'll ask you a question like this. They will say we have an arc, angle theta, lambda is not constant. Lambda is lambda not sine theta. Meaning देखो क्या हो रहा है? If theta is 0, there is no charge. As you go up, charge will increase, charge will increase, charge will increase, charge will increase, charge will increase. Charge is maximum at the top. Then again, charge will decrease, charge will decrease, charge will decrease, charge will decrease, and 0. So it's a non-uniform charge distribution. Then they'll ask you find the field at the center. You can try this as a homework. I'll give you the answer also. You can verify. It is k lambda by r into pi by 2. So it's not actually that difficult if you understood the process. Can you tell me यहाँ पे question में क्या change होगा? Lambda का place में you will get lambda not sine alpha. So integration में this will become sine square alpha. This will become cos alpha sine alpha ना? Isn't it? That is what will change in the integration. Everything else is the same steps. Is that clear what we did? So the whole steps are same. Taking an element, taking components, सब same है. सिर्फ lambda का place में you have to substitute lambda not sine theta here. Theta changes from this, and then that would be the answer. You can verify it for yourself. Clear with the steps. So that is the reason you should know how to integrate, because mains में they won't ask you this kind of question, but advanced में definitely आएगा. Then in advanced में these kind of questions are like you should be happy if you get something like this. There's nothing there. You just put the steps and you'll get an answer. इतना कुछ सोचना नहीं है. Everyone clear with the arc? Then let's see something even better. What if you have a sector? So we have a sector like pizza ka slice. Sigma is your surface charge density. R is the radius. This is angle theta, and this is your center. Find potential at the center. This is not the actual question. The actual question is this. What if you have a full disk? And let's say A is a point on circumference. Find potential at the A is a point on circumference. Find VA. First do the sector. Then we'll go for the disk. K theta lambda. तो भाई कहीं साइन थीटा नहीं रे. पोटेंशियल फील्ड नहीं पूछा. See, it might look scary the sector, but actually it's an easy one. So at a distance x from here, take a thin sector, a thin ring, arc basically. Now see all these points are equidistant from here, and let this distance be dx. So this small arc, if you just make it a straight line, it kind of looks like a rod, where this is dx and this is x theta. So charge on that arc will be sigma into area, which will be x theta into dx length into breadth. So potential due to this arc will be k into charge of the arc into the distance x. Interestingly, you will notice that will be k sigma theta into dx. So potential at the center will be, now integrate all these arcs. K is constant, sigma is constant, theta is constant, integral dx. X goes from 0 to r. K sigma theta r. Check. Field is a little painful, but potential is easy to calculate. Potential, we need to find potential due to arc and then integrate. We don't need it. That's okay. So when you give me a sector, I will take small arcs. So it's like this. If I take arcs like this, I'll eventually complete a full sector like this. Have a look at this. Question is not over. Now the main question is this. How will you find potential for this guy? You have a disk and there is a point on the circumference, not the center. Center would have been easy, na? Put theta 2 pi. If you put theta 2 pi, sector will become a full disk. The question is find the potential at the circumference.
Sir, can you go to the previous page?
Hmm.
Thank you, sir.
Clear, na? So the last week exam, right? The site, there was an update there and the site got crashed. So people who gave the exam before that Saturday or Sunday, I think your data didn't get saved. So yeah, sorry for that. So ignore for this time. Because it has been Saturday, Sunday, na, in log ne kuch maintenance, kuch IP update, something they did, and there was no one there. It was a mess. It is sorted now. Shouldn't be a problem now. But in case your name is not there, leave it for now. Next test is also SHM only, advance. So you have time till Sunday. So make sure to give it. How do we approach this? So now again, forget about the solving and everything. The headache, like I keep saying, how do you even choose an element for this guy? So listen, this is the idea there. You should have seen this. There are few ways to take it. Some people have different ideas, like, I will take a rod like this, I'll do that. Not, it's possible to do that. Integration, thoda, it's bad, but it's possible. Someone wanted to take an arc like this and then integrate. This looks interesting, but it is difficult like this because every instant the angles keep getting messed up. So let me show you how to take for this. So for this, we choose an element. We take a thin sector like this. We take a very thin sector. Again, the theta d theta is so small, I can treat this to be a sector. So we choose a thin sector like this. And just now we derived the formula. So let this radius be r for this sector. So at this point, if you put theta is equal to 0, it will be exactly straight here. If I go here, theta will be, let's say, 20, 30, 60, 70, 80. Where will 90 be? 90 will be exactly on top of it. Na? So so the angles, if you rotate that way, this is theta 0. This point here will be theta 90. Similarly, if you go down, this point just below this will be theta minus 90. You getting how are we covering the sector? So if you put theta 20, this will be the sector. Theta 60, this will be the sector. Theta 89 will be, this will be the sector. So when you go from minus 90 to plus 90, you'll cover the full disk. So we got sectors here whose radius is changing and the angle is also messed up. So from the center, if you drop this is an isosceles triangle. This is R, this is R, this is also theta. So this R will be, you can drop a perpendicular bisector here. This R will be 2 capital R cos theta. That will be the radius of the sector. And just now we derived potential due to a sector is K sigma d theta into small r. देखो K sigma theta r. R is the radius of the sector and theta is the angle. So in this case, for this thin sector, it is d theta. Again, I know you feel like, sir, ye border mein it will be an issue, na? Agreed, it will be an issue. But again, the whole integration d theta is so small, you can ignore that error there. So this will be K sigma d theta. R will be 2r cos theta. You're done actually. So potentiality will be integrated due to all the sectors, which is K sigma 2r cos theta d theta. Limits will go from minus 90 to plus 90. K will be 1 by 4 pi epsilon. This will be sigma 2r. Integral cos theta d theta is sine theta. Limits will go from minus 90 to plus 90. That becomes 2. You get sigma r by pi epsilon. Now it looks like the answer came very easily. That is because you already know the result for a sector. If you don't know the sector, then this would have been difficult. So out of all the different ways of choosing elements, this is the easiest way that I found. Like, it's not mathematically intensive. But getting an idea that I can take an element like this is a little difficult. Clear with this? Any doubts on this? Ask me. So we have choosing a thin sector here. Purja?
Sir, if we take it to be a right triangle with the diameter is the hypotenuse,
Right angle मतलब?
right angle triangle बनेगा ना वो
Yeah.
नहीं दो the it'll join the other end.
This one.
हाँ तो उससे 2r sec.
Then this is thing, na?
हाँ so 2
So
उससे
2r cos theta होना है. अरे this is the hypotenuse record.
अच्छा ठीक है sorry.
वो भी 2r cos theta ही आ रहा है. All clear with this? The integrations will be like this, choosing elements and all. Meaning, why बोल रहा हूँ? देखो ना, actual integration easy था ना? Integral cos theta था. That was easy. Getting an element was a headache. Look at this integration, integral dx. Look at this integration, integral sine alpha, integral cos alpha. The mathematical part is actually the easiest one. Even this integration, if you see, end of the day, we got integral cos alpha, integral sine alpha. None of the places we used really high-fi integrations. but getting it that way is important. Clear? Next one. Let's see something more theoretical. Let's say we have a square plate. Sigma, uniformly charged. O is the center. Point A is the corner. Now, I don't know the potential at O. You can actually calculate this. That also involves little integration, but we're not interested in that. There'll be potential at A also. I want you to find the ratio of potential at the center by potential at the corner. This is a uniformly charged square plate. How will you find the potential at the center and the corner? Ka ratio. Think for a minute, then I'll show you, and then I'll ask you one more like this. These are the good questions actually. Proper mains mein aisa questions hoga. They're not tough to solve, but you have to think. How do we even start this? Let me help you with this thing. Listen, I'll show you one. Now, this square plate, it actually doesn't matter. You take any random shape. Can I say, by thing, the potential at the center here, I know there is still some symmetry here. Potential at the center is proportional to the charge on the plate by the side of the plate. Why is that? Units and dimensions. Potential ka dimension must be kq by a into some constant, right? Constant can keep changing. K is a constant, isn't it? But dimension should be always q by a. For example, dekho. In all the questions we did, if you observe, see what we got the potential here. Kq by a, some constant. Look at this question. Kq by a, some constant. No matter which question you take, see dimensions to match hona hi chahiye. It should be kq by a into some constant. If you look at this question also, rod, dekho, kq, lambda is charged by length. So that is also kq by a, some constant. You're getting it? So no matter which you take, the potential has to have dimension should match. So I can argue the potential at the center is proportional to charge on the plate by side of the plate. Agreed? Because there is no other dimensions here. It's a square plate of side A and charge Q. Whatever will be there, that will be a constant. Everyone agrees with this statement. So this is one important thing there. Now the charge on the plate will be equal to sigma into a square. So this guy will be sigma into a square by a. So this is actually proportional to a. That means the bigger the square plate, more potential you have. So now if I take a square plate of side 2a, so this plate which I'm taking here, This point is A. This point becomes A, isn't it? Now, from this same logic, potential at the A due to the big plate, the side to wake up plate, this becomes the center. This should be 4 times V naught. Sorry, 2 times V naught. Because V is proportional to A, right? If the side is double, potential will double. But this guy is formed by 4 small square plates, isn't it? So this time it will be 4 times potential at A due to the small plates of side A. Does that make sense? Because there are 4 plates here, 1, 2, 3, and 4. Each plate is providing by symmetry. You can see each plate is providing same potential. So the big plate ka potential must be 4 times the small plate. So from here we get, so 2V naught is equal to 4VA. So V naught by VA is 2:1. Are you getting how did we argue with the symmetry? The first thing is figuring out the potential will be proportional to Q by A. बाकी जो होगा वो सब constant होगा. That won't change. Charge on the plate is proportional to A square. So potential at the center is proportional to A. Why am I taking center? Because it's the most symmetrical point. Now, if you take a square plate of side 2A, potential at the center will be double. But this big plate is made of 4 small plates, and each plate must have contributed 1/4 of the total, which is 1/4 of 2V naught, which is V naught by 2. So ratio is 2:1. Is the logic clear, everyone? Sure. Now, you guys try this. Same question, but this time we'll take a cube. Uniformly charged cube. A is the corner, O is the center. Find VU, O by VA. Same thing. Mere falak. Ne purvacha. That is not the answer. Right purvacha. Ne, you get the same answer. So, what's the logic? Same story. Potential to the center is proportional to Q by A. Q is proportional to Q is equal to rho into A cube. So this guy is proportional to A square. So cubes may it will go as a square function. That means if you take a cube of side 2A, at the center, the potential will be 4 times. But remember, this guy is made of 8 small cubes. So this will be 0.8. So VA, now that will become the center of the big cube, will be 4 times V naught. And this guy is made of 8 into VA of the small cubes. So 4 V naught will be 8 times VA. So we get V naught by VA is 2:1. Same answer. Is this clear, everyone? Clear, everyone? Then, so that is about our little symmetries and stuff. Field on an actual line. This is an easy result. You can remember this. So if you have a ring like this, let's say charge is Q and radius R. So actual and meaning line perpendicular to the plane and passing through the center. Let's say this distance is X. So if you take a small piece here, dq, so this guy ka field will be dA. This angle will be theta. This angle also will be theta. You can clearly see only the horizontal components will add up. So EP will be integral dE cos theta. This distance is R. This radius is R. So this is K dq by R square cos theta. So here everything is constant. K cos theta by R square will be X square plus R square integral dq. That turns out to be kq cos theta by X square plus R square. Because here X is not changing, R is not changing, nothing is changing here. So therefore, the field at point P, the result is more important. K q cos theta is adjacent side X by root over R square plus X square whole power 3/2. Remember this. Potential is also easy. Kq by the distance or are equidistant. Root over R square plus X square. And the most important one is the graph. If they ask you to draw the graph E versus X, you can clearly see x0 field is 0, x infinity field is 0. The value will increase and decrease. The maximum will occur at r by root 2. याद है question where you did with this thing? वो hexagon वाला question क्या है याद है? Find the point where the force is maximum. ये question में. If you see, doesn't this function look same? Y by L square plus Y square whole power 3/2. And इसका maximum value कहाँ पे आया था? L by root 2. Look at the function here. Isn't this function also x by r square plus x square whole power 3/2? They're the same functions mathematically. So the graphs will look like this. So you get maximum and maximum values at two positions, r by 2 and minus r by root 2. Remember, that was a mains question. Find the point on the axial line with the maximum field, r by root 2. The graph and the results, they're more important. You can note it down. That is how the graph will look. Right hand side field is I cap, on the left hand side field is minus I cap. So there, that is few shapes. So whatever we did today, take a rough paper, definitely try to integrate on your own. It will help you a lot, right? And you can also try that homework problem, lambda not cos theta. You can check out all these things, try that. If you don't do this, right, you will not remember how to choose elements and all. Right now you're understanding, but trust me, you know, the problem is not yours. Think of like this. Imagine you go to a gym, right? And there's a gym instructor. So you go to the instructor and the instructor takes a 20 kg weight and does dumbbells. He puts it down and you see it and you're like clapping, oh, acha kya, acha kya. And then you go home. And do you think you'll become strong? You are doing exactly the same thing right now. I'm showing you how to do. I'm solving everything. You're listening. It feels good. You think you understood. but nothing has gone into your head. It is just there on the surface level. Until unless you put it on a paper and solve, it won't sink in. So please definitely do that if you're really serious about improving. These small things which you do every day, that is what will make you strong. Sitting one day before the exam and doing 100 questions is useless. So keep that in mind. So that's the last one for the day. So next time when we catch up, we have much better integration. So we'll go a little even higher. We'll be doing field due to a disk, hollow sphere, solid sphere. The results are more important. So we'll catch up on Thursday again. We'll continue from here. Same thing. So I'll see you guys on Thursday at 5:30 as usual. So any doubts in the class notes? Anything else you can stay back or else you're free to leave. So take care, stay safe. I'll see you on Thursday.